Continuation, global atmospheric circulation. The atmospheric circulation also results in variations in the solar energy reaching the surface of the earth. Near the equator, the air is heated. It expands and rises. As it cools after going to a certain height, its density increases and it comes down to the surface, forming subtropical regions with high density. The air from the high pressure areas either moves again near the place which it left or recirculates, forming the trade winds. The remaining air flows towards the poles where it is eventually chilled. This air flows as a layer beneath the hot layer from the poles towards the equator. This takes place not only on the equator but at all the latitudes from equator towards poles. This atmospheric circulation of air helps in creating a moderate temperature on the surface of Earth. So, the rising air creates a low pressure area at the equator continuously, thus forcing a flow in the upper atmosphere away from the equator. The rising air is deflected towards increasing latitudes. A portion of the descending air is deflected towards the equator and completes a circulation cell. So, here we can see the worldwide system of winds: polar cell, Ferrel cell, Hadley cell, Ferrel cell, polar cell. Cold air sinks and flows south. Warm air rises at polar front. Tropical air flows north. Air flows south. Warm moist air rises near the equator. Tropical air carries heat south. Air sinks over subtropical desert zone. Cold air flows north. These are the global atmospheric circulation. The winds that blow in the cells are created by temperature and pressure differences, but also because of the spin of the earth. In each hemisphere, there are three cells, namely Hadley cell, Ferrel cell, and polar cell, in which air circulates to the entire depth of the troposphere. 10 to 15 kilometers above the sea level is troposphere. Hadley cell. Hadley cell, Hadley cell. The largest cell extends from the equator to between 30 to 40 degrees north and south, named after English meteorologist George Hadley. Within the Hadley cell, the trade winds blow towards the equator, then ascend near the equator as a broken line of thunderstorms which form the Intertropical Convergence Zone, or ITCZ, Intertropical Convergence Zone. From the tops of these storms, the air flows towards higher latitudes where it sinks to produce high pressure regions over the subtropical oceans and the world's host deserts, such as hottest deserts such as the Sahara Desert in North Africa. Ferrel cell is the middle cell. So, first one was the Hadley cell. Hadley cell is the largest cell. Okay, largest one. But the Ferrel cell is the middle one. Middle cells, air converges at low altitudes to ascend along the boundaries between cool polar air and warm subtropical air that generally occurs between 60 and 70 degrees north and south. The circulation within the Ferrel cell is complicated by a return flow of air at high altitudes towards the tropics, where it joins sinking air from the Hadley cell. The Ferrel cell moves in the opposite direction to the two other cells, Hadley cell and polar cell, and acts rather like a gear. In this cell, the surface wind would flow from a southerly direction in the northern hemisphere. Polar cell, the smallest and weakest cells. Small plus weak. Okay. Small and the weakest cells are the polar cells, which extend from poles to between 60 and 70 degrees north and south. Air in these cells sinks over the highest latitudes and flows out towards the lateral altitudes at the surface. The continued effect of the three circulation cells, Hadley cell, Ferrel cell, and polar cell, combined with the influence of the Coriolis effect, results in the global circulation. The effect of the spinning earth is called the Coriolis force. The net effect is to transfer energy from the tropics towards the poles in a gigantic conveyor belt. Surface winds. Winds are due to the complex horizontal movement of Earth's atmosphere. Since the gases that constitute atmosphere have weight and exert pressure, which is 760 mm of mercury at the sea level at 14.7 pounds per square inch. This air pressure changes with altitude, temperature, and humidity. Winds always flow from the area of high pressure zone to low pressure, and the greater the pressure, the stronger are the wind currents. The atmosphere has three prevailing winds, which are the major surface winds that blow more or less continuously. They are polar easterlies are the prevailing winds that blow from northeast near the North Pole or from the southeast near the South Pole. Then westerlies winds are those which blow in the mid latitude from the southwest in the northern hemisphere or from the northwest in the southern hemisphere. Trade winds are the tropical winds that blow from the northeast northern hemisphere or from the southeast southern hemisphere towards the equator. Polar cell, Ferrel cell, Hadley cell. Polar cell, Ferrel cell, Hadley cell. No, not there. In the middle. Okay. Polar cell, Ferrel cell, Hadley cell, Ferrel cell, polar cell. Then polar easterlights, westerlights, as E-trade equatorial low doldrums in E-trade, easterlights, polar easterlights, etc. Thus, the climate of an area is the result of many varying factors that affect the region. The climate can be classified into following 5 main divisions, even though each one of them shows large number of variations, like cold temperature, warm temperature, subtropical, and tropical. So atmosphere is a thin layer of multi-layered gaseous veil surrounding the planet Earth. It is about 100 km above the surface of the Earth and separates the Earth from the cold void of space. The atmosphere was initially formed by the gases vented during the geologic tumult of the young Earth, which later become several elements essential to life and helps in cycling of these nutrients between the organism and the environment. It also serves many other functions that make life possible on Earth, such as filtering of radiant energy from sun, insulation from heat loss at Earth's surface, and stabilization of weather and climate owing to the heat capacity of air. The atmosphere is a dynamic body that interacts with all the spheres of life. Earth. The dynamism of the atmosphere can be witnessed every day as it transfers solar heat from the equator towards the pole, creating regular wind patterns such as trade winds. Layers of the atmosphere: exosphere, thermosphere, mesosphere, stratosphere, troposphere. Troposphere: transport and natural phenomena: Mount Everest, clouds, aircraft. Then stratosphere, radio sound. Mesosphere, meteors. Thermosphere, spacecraft, auroras. Exosphere, satellite. So Tropo to strato, then meso, then thermo, then exo. Okay. There are 5 concentric layers within the atmosphere which can be differentiated on the basis of temperature. They are namely troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Troposphere is the lowest layer of the atmosphere in which human and other organisms live. It is approximately 70 kilometers, that means 11 miles in thickness. It is slightly thicker on the equator than on the poles. With an increase in altitude from the surface of the earth, there is a steady decrease in tropospheric temperature. Troposphere is a locus of weather formation of various ecosystems and shows air movement and cloud formation. The important 4 constituents of air, that is nitrogen, oxygen, carbon, and water vapors, are continuously cycling in nature between organism and troposphere through biogeochemical cycles. Then stratosphere is air mass above the troposphere, nearly 40 km thick. The temperature in this layer ranges from minus 15 degrees Celsius to 5 degrees Celsius. Its lower layer consists of significant quantities of ozone, forming ozonosphere. For the ecosystem, ozone layer is an important umbrella that protects them from ultraviolet radiations of sun. Secondly, it also acts as a blanket that reduces the cooling rate of the earth and thus adds to the effect of water. The mesosphere, which is the next higher layer, is characterized by very low temperature and pressure. At about 80 to 90 km above the surface of the earth, the temperature is reduced to 95 degrees Celsius. Above the mesosphere is thermosphere that extends up to 500 km and shows a steady increase in the temperature with increase in altitude. The molecules are widely spaced and are in ionized state. And the outermost layer of the atmosphere is called exosphere. It is made up of only hydrogen and helium. This layer extends up to this much kilometer above the surface of the earth. Then topographic factors. They are the surface features of a region, such as the presence or absence of mountains and valleys, and also known as the physiographic factors. Topographic factors are concerned with the geography of the earth. So once again, troposphere, stratosphere, mesosphere, thermosphere, and exosphere. Topographic factors are concerned with the geography of the earth. The chief topographic factors are direction of mountains and valleys and steepness of slope. For example, south-facing slopes of the mountains receive the most solar energy, which is maximum, and the slope grade equals the sun's angles from the zenith point. North-facing slopes receive the least energy, especially when the slope grade equals or exceeds the angle of sun rays inflection. The climate ranges from warm xeric conditions with wide extremes on south pole to cooler, less variable, more messy conditions on north slopes. Consequently, the western or southern and eastern or northern slopes exhibit different distribution patterns of plants. With the rise in altitude, temperature decreases, rainfall increases, and the wind velocity also increases. This results in increased organic matter of the soil at high altitude and causes increase in nitrogen content of the soil with a fall in pH. Edaphic factors. Edaphic factors include nature, structure, physical and chemical composition of the soil. Though it is difficult to define soil, however, it is the weathered superficial layer of the earth crust in which the living organisms grow and also release the products of their activities, death and decay. It is the foundation upon which all forms of life, and especially most of the terrestrial and aquatic freshwater life, depends. It is the integral part of biosphere, essential for biological cycling of nutrients, and is a main reservoir for the minerals. Soil is the main substrate for roots of the plant. The biomass of the living organisms below the surface of earth is less than that above it in a given area. Then Pdom is the basic unit of soil. Soil is not merely an abiotic factor as it is impregnated with millions of minute bacteria, fungi, plant roots, and small animals. The components of soil are as follows: fauna and flora, bacteria, actinomycetes, fungi, algae, protozoa, rotifers, nematodes, earthworms live in the soil and very rarely come out of it. Organic matter, humus is the dark brown to black product formed from the bacterial decomposition of dead animals and plants. The inorganic matter, the soil solutions. Water is the major nutrient solvent in the soil. Minerals dissolved in nutrients solvent make soil solutions. The soil atmosphere, aeration, like that. Formation of soil. Factors involved in the formation of soil. Formation of soil involve 5 interdependent factors as given below. Parent material. It is the unsolicited mass from which the soil forms. It is derived from the parent rock or from the transported material. It is important in determining the chemical composition of soil depending upon whether it is derived from an igneous, sedimentary or metamorphic rock. Weathering of the parental material take place: disintegration, physical weathering, and decomposition, chemical weathering. Weathering is confined to only the top few meters of the soil because physical, chemical, and biological stresses reduce with depth. Physical disintegration is the first stage in the transformation of parent material into soil. Temperature fluctuations cause freezing and thawing of rock, result in its contraction and expansion, forming cracks in it. Cycles of wetting and drying cause the soil particle to be upgraded to finer size. Water enters into the rock crevices. Further changes may be brought about by the biological process. Then climate. It affects the development of the soil. Temperature and rainfall determine the weathering of rock, decomposition of minerals, organic matter, and leaching of materials. Biotic factors. Plants, animals, bacteria, and fungi contribute to the formation of soil. Vegetation gives color to the soil and prevents its erosion. Topography. Less water is retained on the steep slopes than a flat surface. Soil is less developed in slopes. It begins with the weathering of rocks and their minerals. The process begins. So weathering involves 2 types: mechanical breakdown, chemical modification. Mechanical breakdown, small particles turn into small particles. The material transported from one area to another by wind is known as loess. The soil may consist of slightly weathered material with fresh primary minerals, or it may be intensely weathered and consists of highly resistant minerals such as quartz. Chemical modification. Acids. Lichens and mosses produce acids. Secondary minerals are formed. Iron in this way get oxidized to a red ferric state, or it may be reduced to grey ferrous state. The mantle of unconsolidated material is called the regolith. The thickness and the kind of rock from which it is formed and the degree of weathering affects the fertility of the soil profile. If the soil is cut vertically, the soil profile can be distinguished into 5 horizontal layers. They are the horizons O, A, E, B, and C. O is the organic layer and others are mineral layers. Below these 5 layers lies a non-soil R horizon. In some of the soils, all the horizons are very distinct, but in others they appear to form a continuum as the boundaries are not clear. O horizon is the most important ecologically and is formed by originally decomposed material. It can be subdivided into 2 layers, O1 and the litter layer. O2 is the humus layer. Other layer shows O1 layer shows seasonal and regional variations in its thickness. In the temperate zone, it is thickest in autumn and thinnest in winter. It is usually absent in the cultivated ecosystems. O1, O2, litter layer, humus layer. Okay. Soil layer O1 alpha, O2 beta, litter layer humus layer, upper mineral layer rich in organic matter. A is a granular layer. Zone of maximum leaching consists of suspended and dissolved materials. Zone of eluviation rich in clay, iron, aluminium and humus. Then weathered minerals, unweathered minerals or the parent rock material. So different layers are here, soil layers, alpha, beta, litter layer, humus layer, upper mineral layer rich in organic matter, E is the granular layer, A upper mineral layer rich in organic matter, B is the zone of eluviation rich in clay, but that only comes O, A, E, B, C, R. A means upper mineral layer rich in organic matter. E, it is a granular layer, zone of maximum leaching, consists of suspended and dissolved minerals. Then B, zone of eluviation, rich in clay, iron, aluminium and humus. Weathered materials on C and weathered materials or the parent rock material. O, A, B, C. So here, A horizon is characterized by an accumulation of organic matter, clay, inorganic minerals, and some dissolved salts. This is the zone with maximum biological activity. The E zone has granular appearance and it's whitish in color. This is a zone of elevations, the maximum leaching, the downward movement of water. Suspended particles and dissolved minerals make it granular in appearance. B horizon accumulates silicates, clay, iron, aluminium and humus and are also known as zone of eluviation. Below this zone, sometimes clay pans are formed by the downward leaked out clay. C horizon contain the weathered and solidated earth material below A and B zone. R unweathered consolidated or parent rock material. Soil color brownish black or dark brown color indicate large quantities of humus in the soil. Red and yellow soil derives their color from the presence of iron oxide in them. Quartz, kaolin, carbohydrates of calcium and magnesium, gypsum and various salts of iron have whitish and grayish color to the soil. Soil texture. Gravel, sand, slit, clay. Gravel and sand particles can be seen with the naked eye, but not the slit or clay. Clay controls the most important properties of soil. The soil texture is a percentage by weight of sand, slit and clay. Texture classes, namely sandy soil, loam and clay. Loam is an ideal agricultural soil and has approximately equal portions of sand, slit and clay. In case of sandy soil, aeration is excellent, drainage is excellent, nutrient holding capacity low, water holding capacity and Workability, tillage easy and low. Loam is amazing, like aeration is good, drainage is good, nutrient holding capacity medium, water holding capacity medium, workability moderate. Clay, poor aeration, drainage poor, nutrient holding capacity high, water holding capacity high, workability tillage difficult. Pore space. Coarse structured soil has more pore spaces. Finer textured soil has small pores with greater availability of water and chemical activities. Soil depth. Other forms with little crystallinity are vegetal carbon and black fume in case of carbon. sulfur. Cysteine and methionine contain sulfur. Cysteine and methionine contain sulfur, and glutathione is a detoxification agent and antioxidant. Protect against exposure to ultraviolet light, X-rays and radiation. Next comes laws of limiting factors. The existence, survival and the sustainable growth of an organism depends on the presence of some total of all the essential materials and physical conditions required by it at the given time and space. Macronutrients, micronutrients and physical factors like temperature, humidity, light, pressure and topography of place that limit or control the growth of an organism of population is called a limiting factor. This is from by Liebig. The concept of the limiting factors was given for the first time by Justus Liebig in 1840. He stated the law of minimum for the essential chemicals required for the plant growth. In his studies, he found that the substances required by plants in large quantities are not limiting the growth of the plant. Rather, the ones required in small amounts or traces limit the plant growth. Liebig's law of minimum. Under steady-state conditions, the essential materials available in amounts most closely approaching the critical minimum needed will tend to be the limiting one. Boron acts as a limiting factor. This law is only applicable only under steady-state conditions, that the inflow of balances and outflow of energy and minerals in the organism or population. Growth and reproduction are not steady-state condition. Factor interaction states that high concentration or availability of some substances or some factor or factors other than minimum, one may modify the rate of utilization of the later. Sometimes organisms are able to substitute closely related substances for the one that is deficient in the list of requirements. Strontium can be substituted for calcium by mollusks. Shelford's law of tolerance. V.E. Shelford in 1913 stated the law of tolerance. So maximum of some minerals also act as limiting factors. So he saw upper and lower limit of tolerance is there. They will lead to coma, then complete death. Combined concept of limiting factor. The combined concept of limiting factor states that the presence and success of an organism or a group of organisms depend upon a complex of conditions. Any condition which approaches or exceeds the limit of tolerance is said to be a limiting condition or a limiting factor. Lower limit of tolerance, upper limit of tolerance, zone of stress, zone of coma, optimum range. The degree of tolerance is expressed in terms of steno or ure. Steno or ure, meaning narrow and wide range of tolerance respectively. They can be used as a prefix to any of the environmental factors like stenothermic, narrow range, and eurythermic, wide range. Stenohaline and euryhaline, stenopelaphagic and euryphagic. Antarctic fish is stenothermic. Desert fish is eurythermic. Organisms with a wide range of tolerance for all the factors are most widely distributed than those with a narrow range of tolerance. Frog and desert fish are widely distributed as they have a wide range of tolerance. When the conditions are not optimum for a species with respect to one ecological factor, the limits of tolerance may be reduced with respect to another ecological factor. The resistance of the grasses to drought is reduced when nitrogen is limiting factor in the soil. More water is required to prevent wilting at low nitrogen levels. Many a times it is observed that organisms are not actually living under optimum conditions with respect to a particular factor. Some other factors are more important for their growth. Tropical orchids grow better in full sunlight than in shade, provided they are kept cool. Therefore, the nature they are always found in shaded places to avoid the heating effects of direct sunlight. During the reproductive phase, the environmental factors are most likely to become limiting. Eggs, embryos, larvae, and seedlings have a narrow range of tolerance for most of the factors. Migratory birds and fishes travel long distances to lay their eggs in those geographical places which are more suitable for their eggs and young ones. Thank you so much for listening.